All right, Addie. Well, since the other math was a little too easy for you, we are going to move on to algebra. It's going to seem a little bit easy at first, but let me tell you, it accelerates quickly. So it's going to get hard fast. So don't worry if you're still reviewing a little bit in the beginning. It's going to get tricky. It's going to challenge you, and it's going to be good. So let's jump right in, okay? First of all, look at this meme. Kevin was starting to think that maybe his mom wasn't coming back. It's funny. It's funny because how long do you think he's been sitting there? Anyway, okay. All right, let's do some addition and subtraction of fractions. Here we go. So you probably remember this. When you're adding or subtracting fractions that have the same denominator, all you do is add or subtract the numerators, and then you keep the denominator the same. So for example, these have the same denominators. So let's look at the numerators. 5 and a 2, we're just going to add them together. So the answer is going to be 7, and then the denominator stays the same, so it's 7 over 11. Okay, what about if we are subtracting? If we are subtracting, it's just the same. So the denominators are the same. This time we're just going to subtract 5 minus 2, and the answer is going to be 3 over 11. Easy peasy, no problem, right? Okay, what if the denominators are not the same? Now it's going to get a little trickier here. So let's look at this problem. We have 1/3 plus 2/5. So the first thing we need to do is to rewrite the problem, this time with equal denominators. So we find a common denominator. How do we do that? Well, the way I sort of remember doing it is taking the biggest of the denominators, which is 5. So when I look at 3 and 5, I'm going to say, well, 5 is the biggest. Let's take that one. What if I make this a 10? If I make this a 10, does 3 go into 10? No, it doesn't go into 10 evenly. So let's find another number that 5 goes into. So it can't be 5, it can't be 10. How about 15? So if we turn the 5 into a 15, does 3 go into 15? Yes, hallelujah, it does. So we can make both of these numbers or fractions with a denominator of 15. So let me move this out of the way, and we'll start with 1/3. 1/3 has to be something over the 15. So to change from 3 to 15, I have to multiply that by 5. So to change the 1 to whatever else, I have to multiply it by the same number. So this is going to be 5 over 15. Okay, what about the 2/5? So we want to make 2/5 equal something over 15. And to get the 5 to turn into 15, I'm going to multiply it by 3. So I have to do the same to the top. So 2 times 3 is 6. Okay, so now I have made both of these fractions into a common denominator. So let's do the math problem. Let me subtract some of these things. Okay, so now the problem is the same. It was 1/3 plus 2/5. This is actually the same problem, 5/15 plus 6/15, and the answer is it's going to be something over 15, and we just add the numerators, 5 plus 6, so that makes 11. The answer is 11 over 15. Easy peasy. Let's do another problem. This time we're going to do 2/3 minus 1/8. So again, let's make these have common denominators. I'll put it down here for now. Okay, so what do? I take the biggest of those denominators, which is the 8. And what if we double it? If we turn that into a 16, 8 will go into 16, right? Will 3 go into 16 evenly? No, it doesn't. So can't use that. What if I do, instead of doubling 8, what if I triple it? What if I do 8 times 3 and do 24? Okay, that works because 3 goes into 24. Yay, okay, so that's going to be the common denominator. 2/3 is going to be something over 24, and 1/8 is going to be something over 24, right? So let's do the top one first. How do I get from 3 to 24? What do I have to multiply? So I have to multiply it 3 times 8, right? So I have to do the same to the top. 2 times 8, and it is 16. So that's 16 over 24. What about the bottom? Now to get to 8 to 24, I had to multiply by 3. So let's multiply the top by 3, and we're going to get 3 over 24. Okay, easy peasy. Now we just have to subtract these fractions because that was the original problem. So we have to subtract 16 24ths minus 3 24ths, and that's super easy because the answer is going to be 16 minus 3 is 13 over 24. Easy peasy. All right, let's talk about mixed numbers. A mixed number is the sum of a whole number, so there's the whole number part of it, and a fraction, which is right there. So when we look at something like this, it does not mean 13 times. It doesn't mean that. It actually means 13 plus 3/5. And that's important to remember when we're doing some of these problems. So we're going to start adding and subtracting mixed numbers. Okay, so what if we have a problem like this? Whew, this is getting more complicated. Do you see what I mean by getting complicated quickly? So here's what I'm going to do. I'm going to stretch this out, and I'm going to remember that 13 and 3/5 is the same as 13 plus 3/5. So this is really a problem like this. And this is actually not as hard as it seems. We do have to find common denominators because these are not the same denominators. So let's pull that part out of the problem and just add those things together. Maybe I'll do it like on top of each other like this. Okay, so let's find a common denominator between 5 and 8. So 8's my bigger number, so what if we double it? It would be 16, right? But 5 doesn't go into 16, so that won't work. What if we triple it? It's 24. That won't work either. What if we quadruple it? 8 times 4 is 32. 5 does not go into that. Nope, not going to work. What if we do 8 times 5? 40. Yes, 5 goes into 40, so that's going to work. So my common denominator is going to be 40. Now let's change 3/5 into 40. So what did we have to do? 5 times 8 is 40. 3 times 8 is going to be 24. Okay, you can see how you have to have all of these math problems just dripping off your tongue. Now let's change 8 into 40. We had to do times 5 for that. So let's do times 5 for the top. So that's just going to make a 5 here. All right, now let's put all of these back in the original problem. Okay, so if we do this, the first thing I'm going to add together is these fractions, 24 over 40 and 5 over 40, and I get 29 over 40. And then I can add these other parts, the whole numbers, because we can't forget about those. So we just add 13 plus 2, super easy, 15. So there's our final answer. Okay, let's move on to subtraction now. So here's what we're going to do. It's the same numbers. You recognized them before. 13 and 3/5, 2 and 1/8. And we're just going to subtract this time. That's the only thing that's different. So the only thing is I can't separate everything out like I did kind of before because I have to subtract the whole numbers as well. So I got to keep track of that. So what I'm going to do is I'm going to change these fractions. 3/5 we already figured out is going to be the same as 24 over 40. And then 1/8 we already figured out is going to be the same as 5 over 40. And now they have common denominators. So we're going to subtract 13 minus 2, and that makes 11. And we're going to subtract 24 40s minus 5 40s, and that is going to be equal to 19 over 40. Easy peasy. So that is our final answer. Okay, so now we are going to move on. Borrowing. I wrote this word here because I've got to show you something super important. Okay, so let's pretend that these were kind of different numbers. 13 and 3/5 minus 2 and 7/8 instead of 1/8. Now, okay, let's go through it like it's a new problem. 3/5 and 7/8, we have to find common denominators. So we're gonna change these, and we already figured out that the common denominator, the bottom number, is going to be 40. Okay, so how do I turn 5 into 40? I multiply by 8. So 8 times 3 is going to be 24. And so this is the same fraction as before, but this is not 1/8 anymore, it's 7/8. So to go from 8 to 40, I multiplied by 5. So I have to multiply the top by 5. So now the numerator is going to be 35 over 40. Okay, so let's erase these and let's put these back like this is the problem, because this is the problem. It's just written with common denominators. Okay, so you can see that there's a problem. I can still do 13 minus 2, I'll get 11, but I can't do 24 minus 35 because I'll get a negative number there, and we can't do that. We need to borrow. So if I borrow, the goal is to make this number bigger. It has to be bigger than 35 so I don't end up with a negative number, right? So how can I make this number bigger? I borrow from the 13. And you might remember that 13 can be written as the same as, that's Nora in the background. She's happy and playing with her toys, so it's all good. Okay, there's your toy back, Nora. Oh, okay, so if I want to turn the 13 into a 12 with a fraction over 40, what's the same as the number 1? It's 40 over 40, because check it out, it's kind of what we discussed before. This is 12 plus 40 over 40, which is the same as 12 plus 1, and that equals 13. So if I want to borrow from the 13, I totally can. I make this a 12, and then I add 40 to the top. I don't have to add 40 to the bottom because it's 40 over 40. So the denominator stays the same. So all I have to do is add 40 to the top. So 40 plus 24 is going to be 64. I did that in my head. Is that right? I'm pretty sure it's right. Okay, so now I have borrowed and I've made it so this number is bigger than this number. So I can just go ahead and subtract. So I'm going to do 12 minus 2, which is 10. And then 64 minus 35, which turns out it's going to be 29 over 40. Okay, easy peasy. I'm going to pause for now and play with Nora a little bit, and I will get back to you later. Okay, so far, Addie, brilliant and well done on that other part. Now we are going to move on to lines and segments. I know this lesson covers a lot, but I know that you got this. First of all, let's go over what a mathematical line is. Now, a mathematical line is interesting because it's actually almost an imaginary thing because you can't draw it. It's like you can't really draw it because it has no width. Like this is as skinny as it could possibly be, and it has no ends. No ends. So these go on forever. And obviously you can't draw that. So a mathematical line is a straight line with no width and no ends. To show the location of a mathematical line, you draw a pencil line like this, and you put arrowheads to show that it goes on forever. And there you go. And you can name a line by naming any 2 points on the line, and then you use an overhead bar. So kind of like this. This line could be called line AX, but I would have to put a line over it like this, just like that, right? The line could also be called XA with a line over it, AC. You get the idea, CA, it could be XC. All of these would have an arrow with 2 arrowheads over it. Okay, you can also have a line segment. And a line segment just looks like that. It's just a piece of a line because it does have end points. That's what those are called. That means it has an ending right there. And to name a line segment, you can call this MC, and you would put just a line like that, and it doesn't have arrows, so that just means it's a line segment. You can also call this CM. Let's go over an example. Ready for an example? Example 1.1. All right, so we are going to go over this math problem. We're going to do, looks like a little bit of subtraction followed by a little bit of addition. Okay, so these are fractions. Let's look at the denominators to see what we need to do next. Well, they are not the same denominators, so we need to figure out a common denominator. All right, so that is the first step. Make all of these a common denominator. Now I'm going to take the biggest one and I'm going to start doubling it, or at least multiply it by 2. 22. Do these numbers go into 22? Now I'm just going to look at 6. Does 6 go into it? Because if 6 does go into it, then obviously 3 goes into it because 3 goes into 6. So that eliminates a step. So it doesn't go into 22, so let's look at the next one. How about 33? Nope, 6 doesn't go into that evenly without a remainder, so I'm going to look at the next one. How about 44? No, same. 6 doesn't go into that. 55? Nope. But look at this. 66. Does 6 go into it? Yes, it does. How about 3? Of course it does, because 3 goes into 6, so obviously 3 can go into 66. Okay. The common denominator is going to be 66. Now, how do I get from 11 to 66? I multiply by 6, so I'm going to have to multiply the top by 6, and I will get 60. Okay, what about the next one? We are starting with the 6, and I want to get to 66, so obviously I need to multiply that by 11, so that means I need to multiply the top by 11. That makes this 55. Okay, sweet. We're on a roll now. Okay, what about this last one? I want to turn this into 66, so I'm going to write the 66 on the bottom. What do I need to do to make that a 66? Well, I need to multiply it by 22. So if I multiply that by 22, I must need to multiply the top by 22. You got to do the same thing to both sides. So 1 times 22 is 22. All right, now this has become a much easier math problem, hasn't it? 60 minus 55 plus 22. Let's start with this. What's 60 minus 55? And that is going to be 5 over 66. I'm still going to add that 22. And I get 27 over 66. Now, when you take a test makers are not going to like this answer. In fact, they're not even going to list that as one of the options. A, B, C, or D, none of them will be 27 over 66. I can guarantee, because we have to simplify that or reduce this fraction. Okay, so what number goes into both of these to make it more simple? Well, I know that 3 does, because this number is divisible by 3. How do I know? 7 plus 2 is 9, and 9 is divisible by 3. Therefore, 27 is divisible by 3. That's a rule. Did you know that? So cool. Okay, so what's 27 divided by 3? 9. What's 66 divided by 3? 22. This actually cannot be reduced anymore, so that's the simplified form, and that's the final answer. Sweet. Okay. Okay, uno más example, and then we are all done. Let's go over example 1.2. And this says, this is an interesting one. This one's kind of fun. It says segment AC, so AC would be this segment, that whole length, measures 10 1/4 units. And it just says units. It doesn't give centimeters or whatever. And then it says segment AB measures 4 3/7 units. And then it wants us to find BC. So this is a two-step problem. You have to figure out what the problem is. What do you do with these numbers? So if segment AC is 10 1/4 and they only want to know this part of it, then we have to subtract out AB. So it's going to be, BC is going to be equal to AC minus AB. Make sense? Okay. So then, I'm going to write it again, this time with numbers. BC equals AC, which is 10 1/4, minus AB, which is 4 3/7. Okay, so now I'm going to do some erasing so I have a little bit more space to work. Okay, and let's solve this problem because this is the problem they want us to solve. And it is just 10 and 1/4 minus 4 and 3/7. So we're basically subtracting mixed number fractions. So step 1, let's make these common denominators. We've got a 4 and a 7 here. So 7's my bigger number, so I'm going to find a multiple that works for 4 and 7. So 7 is not going to work by itself. How about 7 times 2? 14? Nope, 4 doesn't go into that. What about 7 times 3? 21? Nope, 4 doesn't go into that either. What about 7 times 4? 28. Ooh, that one works because 4 goes into 28. So now let's rewrite this problem, this time with our denominator of 28. Okay, so I need to turn 1/4 into something over 28. What do I need to do to the 4 to turn it into 28? So 4 times 7 is 28. And so what do I have to do to the top? I also have to multiply by 7. That's going to make this 7. All right, now let's look at this problem. Sorry, I got confused for a second. 28 divided by 7 is 4. So basically what I have to do to this to make it 28 is multiply by 4. So I have to multiply the top by 4. So 3 times 4 is going to be 12. Oh, I knew they were going to do this to us. I knew it. Guess what? Look, we're going to have to borrow. We're going to have to borrow because we can't do 7 minus 12. That's not going to work. So we're going to have to change the 10 into, actually, let me write it like that. And let's write 9 and 28 over 28. Do you see how 9 plus 1 is the same as 10? And now we just need to add this to here so we can borrow. And of course the denominator is going to stay the same. And the top is just going to be 28 plus 7. And now I can erase this and make this 35. So now I have 9 and 35 28ths minus 4 and 12 28ths. All right, now we can finally solve the problem. So it's going to be something over 28. What is 35 minus 12? And 35 minus 12 is 23. And then what is 9 minus 4? 9 minus 4 is 5. Okay, now we have to double check one more thing. Is this an answer that is acceptable or can we reduce it anymore? And it turns out we cannot reduce it anymore. There's not a number that goes into both of these, 23 and 28. They don't have a common factor. So this is the final answer, 5 and 23 over 28. And I know you're going to be super sad because this lesson is over, but this lesson is over. Can you believe it? It went by so fast. All right, love you, Addie. Good luck on your homework. Bye.